Problem number 4 gives us the sine of theta is equal to negative square root of 2 over 2. So for A, we're asked to find all angles between 0 and 2 pi that make this guy up here a true statement. So if we draw out our unit circle, sine is negative in quadrants 3 and 4, and if I want a sine value of square root of 2 over 2, and this here we want it negative, I'll need to be at 45-degree reference angles coming back up this way. So I've got these two spots right here. So this guy is going to be at, now we can count our pi's over 4, so 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So our answer is that theta would be equal to 5 pi over 4 and 7 pi over 4. For B, we're asked for angles between negative pi and pi. So they're the same angles. Okay, so here's, let's look at our diagram. Negative pi is from here to here, and positive pi is that angle. So to hit these guys, notice positive pi from 0 to pi, there are no answers. Because that, guys, is this up here. So between when I wrote that, I should have said between 0, I said between theta. So between from 0 to pi, there's no solutions. However, our two solutions are going to occur between negative pi and 0, so back on this side. So as we count backward, this guy right here, I'll do it in a different color, let's do it in purple, is negative pi over 4. This is negative 2 pi over 4, and this is negative 3 pi over 4. So what I did was I worked backward in this direction. So our solutions for this are the two angles, negative 3 pi over 4 and negative pi over 4. Those are the only two angles between negative pi and pi that will have a sine value of negative square root of 2 over 2. For C just says, what are all? So theta is a real number. So give me every possible angle that works. Well, all the multiples of 5 pi over 4, okay, plus 2k pi. So 5 pi over 4 is where we start, and then we start wrapping around the circle. And every wrap around gives us a new solution. And the other one is 7 pi over 4. Okay, so there they all are.